In this video, I will teach you about the power rule used to find derivatives of functions through the use of three distinct examples. Before we begin, first you'll have to understand the formula used for the power rule. The formula is when f of x equals x to the n power, the derivative of f of x equals n times x to the n minus 1 power. This is very simple, and I'll show you by doing a few practice problems. We will first start out with a basic problem. The problem is to find the derivative of f of x equals 4x squared minus 2x plus 9. First, we do 4 times the exponent connected to x, which is 2. We then subtract that exponent by 1. Then we multiply negative 2 by the exponent connected to x, which would be 1. We then subtract that exponent by 1. Finally, we multiply 9 by the exponent connected to x, which would be written as x to the 0 power. We then subtract that exponent by 1. Next, we simplify. The first part becomes 8x to the first power. The second part becomes negative 2x to the 0 power. And the third part becomes 0x to the negative 1 power. Finally, we simplify fully. 8x to the first power can just be 8x. Anything to the 0 power is just 1, so negative 2x to the 0 power just becomes negative 2. And 0 times anything is 0. So 0x to the negative 1 power becomes 0. This gives us our final answer. The derivative of f of x equals 4x squared minus 2x plus 9 is 8x minus 2. Now that you have a handle on the basics, we can move on to some more complicated problems. The next problem is to find the derivative of f of x equals 20x to the 5th minus 7x to the 4th plus the 5th root of x minus 10 over x to the 7th. First, we need to get each part to the point where we could be able to work with them. 20x to the 5th and negative 7x to the 4th stay the same. The 5th root of x can become x to the 1 over 5 power, and negative 10 over x to the 7th can become negative 10x to the negative 7 power. Next, we multiply each coefficient by the exponent connected to its x and subtract that exponent by 1. 20 times 5 is 100, and 5 minus 1 equals 4. Negative 7 times 5 is 28, and 4 minus 3 equals negative 7 times 4 is 28, and 4 minus 3 equals 3. 1 times 1 over 5 is 1 over 5. And 1 over 5 minus 1 equals negative 4 over 5. Finally, negative 10 times negative 7 is positive 70, and negative 7 minus 1 equals negative 8. The next thing we need to do is to get all the exponents to be positive. In order to do this, you simply move the negative exponent to the denominator. 100x to the 4th and negative 28x to the 3rd can stay the same. 1/5 x to the negative 4 over 5 power becomes 1 over 5x to the 4 over 5 power, and 70x to the negative 8 becomes 70 over x to the 8. Finally, we need to get everything back in its original form. In doing this, we are given our final answer. The derivative of f of x equals 100x to the 4th minus 28x to the 3rd plus 1 over 5 times the 5th root of x to the 4th plus 70 over x to the 8th. Finally, we will use the power rule to find the third derivative of a function. The problem is to find the third derivative of f of x equals 12x to the 3rd minus 5x squared plus 70x minus 1. First, we need to find the first derivative of the function. To do this, we multiply each coefficient by the exponent connected to its x and subtract that exponent by 1. 12 times 3 is 36, and 3 minus 1 equals 2. Negative 5 times 2 is negative 10, and 2 minus 1 equals 1. 70 times 1 is 70, and 1 minus 1 equals 0. Finally, negative 1 times 0 is 0. After we simplify, the first derivative of f of x is 36x squared minus 10x plus 70. Second, we need to find the second derivative of the function, or the derivative of the first derivative. 36 times 2 is 72, and 2 minus 1 equals 1. Negative 10 times 1 is negative 10, and 1 minus 1 equals 0. Finally, 70 times 0 is 0. After we simplify, the second derivative of f of x is 72x minus 10. Finally, we will answer the question by finding the third derivative of the function, or the derivative of the second derivative. 72 times 1 is 72, and 1 minus 1 equals 0. Negative 10 times 0 is 0. After we simplify, we find that the third derivative of f of x equals 72.